Hello everyone, my name is Danish and you're watching Code. In this tutorial, we'll go through some basics of reversing. Knowledge of C++ is required for this tutorial because without C++ it will be extremely hard to understand anything. You should know about classes, inheritance, pointers, and dynamic memory allocation. One of the biggest differences between C and C++ programming is classes. In C++ we have classes, which allows us to organize code in a very nice way by grouping functions together. In C++, structs and classes work exactly in the same way. The only difference is the members of a class are private by default, whereas they are public in a struct. That's all. Other than that, it's the same thing. Every variable in C++ has a data type, and every data type has a range and size. GTA 3, VC, and San Andreas are 32-bit. In a 32-bit process, the range of int is -2 billion to +2 billion, and the size is 4 bytes. The data is stored in binary, also known as base2. But when we are writing code, we write numbers from decimal system, also known as base 10. And the compiler converts it to binary. It saves us a lot of time and makes the code readable by using decimal system, which we are using in our daily lives for all kinds of calculations. Something you should know about binary is that there are only ones and zeros, because 1 means on and 0 means off. It is the language of the computer and your CPU only understands binary. Now, there is a problem with decimal system. The problem is that you need to write and remember too many numbers, which can be confusing, and we might make mistakes. So the programmers use hexadecimal number system to represent big numbers. It is also known as base 16, as there are 16 digits. We put the prefix 0x at the start of a number to instruct the compiler that it's a hexadecimal number. We can convert a hexadecimal number to a decimal number very easily just by opening the calculator. If you're on Windows 10, we should be able to see the decimal and binary representation of the hexadecimal number. In computers, we have RAM, which stands for Random Access Memory. It is a hardware which is installed on our motherboard. When we start a program, it is loaded into our RAM because RAM is very fast due to random access, which simply means that every address in RAM will take the same time to access despite of its location in the RAM. RAM is divided into bytes. This means that every address in RAM can hold a value of 1 byte in size. This 1 byte can be any data. It can be pixels of a picture, audio, or just some text. If the process is 32-bit, then your CPU can access 4 bytes of data at a time from RAM. So let's see how an int data type looks like in RAM. We start off by including some headers. We then define a variable of int data type and name it amount, and then we assign the value 90,000 to it. So let's print 3 things: the address, decimal, and hexadecimal representation of amount variable. We can see the decimal and hexadecimal representation of amount variable. Let's open the process in Cheat Engine. We can see the value by going to the address. These are the 4 bytes of amount variable. For the sake of simplicity, we can print each byte separately to understand better how the amount variable looks like in memory. We're using the data type unassigned int8 for the variable amount address because its size is 1 byte, which is 8 bits. Something should be noted that there is a unary asterisk, which means that this variable is a pointer variable. This data type will allow us to access each byte of amount variable separately. If the data type of this variable was 4 bytes, then we would be accessing 4 bytes of data when dereferencing. we are able to see the hexadecimal representation of the values from these 4 bytes. The reason we are using 4 bytes for int is because the more bytes you have, the higher range you can have. The address of a variable will always point to its first byte. If we go to its address in cheat engine, we can see the same bytes again. To summarize it, since the size of int is 4 bytes, it uses 4 bytes in memory. Each byte has a separate address, and the address of every variable points to its first byte. This means that if we want to access the remaining bytes, we can simply increment the address of the variable, just like we did in the loop. One may wonder, why would you want to do this? Well, here's the thing, you don't have to. It totally depends on the situation. It's usually done in modding. Now let's define a player class. Let's see how it looks like in memory. So we defined 4 members for this class. The first member is name, which is 20 bytes in size, and then we have the skin ID, which is 4 bytes in size, and then we have health, which is also 4 bytes in size, and finally we have armor, which is also 4 bytes in size. Define a constructor for the class to initialize its members. Create an object of the class and name it myPlayer. The first parameter of the constructor is a string. It can take 20 characters maximum. The last character is used for null terminator, which indicates that it is the end of the string. Here myPlayer is an instance of the player class. When we have an address of an instance to this class, we can use it to access the members of the class. We can access the skin ID member of an instance if we increment the address of the instance by the size of name, which is 20 bytes. For health, we have to increment the address by 24 bytes. For armor, we have to increment the address by 28 bytes. If we assume that the address of an instance is 0x500 ECE65, then those are the bytes that we have to increment the address with to access a member. Now let's print the address and size of myPlayer object. You know what? We can rename the string to something better. So I'll rename it to she said she was 18. Keep in mind that the size of the string is 20 bytes, including the null terminator. So if we go to the address in cheat engine, we can see the ASCII representation of the string. We can also see that exact 20 bytes are used. This final byte under F7 is the null terminator, which indicates that it is the end of the string. This 64 is the second member of myPlayer instance. It is the skin ID. The beauty of a pointer is that we can access any data from RAM by using its address. We can declare a new pointer and name it pplayer and assign the address of the instance we want to access. Right now I have myPlayer object. This is usually not the case. You do not have an object. You'll most likely have only the address. So we can also directly assign the hexadecimal address to the pointer. Now we can print the members of the class. We can see the output. There is an alternative way to access the members of a class. This is usually when you have an address to a class, but you do not know how the class looks like. So this is how you access it. The unary asterisk before casting instructs the compiler that we want to dereference a pointer. We have to write the proper data type. If it's int, then we have to write int. If it's float, we have to write float. As you can see that we are first converting or casting an address to a pointer, and then we are dereferencing that pointer to get the value from it. Running the program shows that the output is exactly the same for both techniques. So those are the two ways of how you can access an instance of a class from a memory address. Both techniques are fine, but the first one is very clean. That's all I have to say. Hopefully I'll see you guys in the next video.